In my previous video, I introduced the concept of a relator. In short, a relator is a tool which shows the relationships between different objects. Theories, laws, metaphors, formulas, and etc. are all examples of relators. Recently, I have discovered a possible useful application of relator diagrams. With some simple mathematics, relator diagrams can be used to predict the usefulness of a relator. Before exploring this method, I would like to provide some more details about relators. I will be borrowing some terminology from a field of study which focuses on the levels of measurement. If unfamiliar with these terms, please pause the video and read the material provided on screen. A preliminary step to quantifying the usefulness of a relator is drawing the relator's relator diagram. Here are some examples of what relator diagrams will look like. If two systems, which are collections of objects, are contained within the same boxes, the systems share some properties. These properties or labels are not listed alongside the relator for reasons I will explain later. Note that the order of the objects matter. For example, system AB is different than system BA. I will now describe the steps required to create a relator diagram. As an example, I will be using a simplified version of the Mohs hardness scale, which considers 4 objects and 4 outputs. This ordinal scale is an example of a relator. After selecting a relator to analyze, the first step is to create all possible representations of the relator by placing the objects in a one-dimensional space. Diagrams that represent the relator are considered consistent, while those that do not are considered contradictory. The next step is to create as many boxes as there are systems of one object. Because there are 4 objects, T, G, C, and F, I have created 4 boxes. After choosing one of the consistent diagrams, labels are then added to the boxes, which describe some spatial property of the systems of one object. These systems are then placed into boxes. If a box is left unused, it can be removed from the relator diagram. Once the first relator diagram has been made, the following step is to use the relator diagram to try to create a contradictory diagram. The labels of the boxes can be changed, however, the number of boxes and the system locations cannot. The diagram pictured above is contradictory because it is an entirely different ordinal scale created using the relator diagrams below. If no contradictory diagram is created, then the relator diagram is complete. However, if one is found, then there are 2 options. Either more relator diagrams with systems of one object can be developed, or a relator diagram with systems of 2 objects can be created. For ease, I will refer to the first type as an order 1 relator diagram and the second type as an order 2 relator diagram. Because a contradictory relator was found, I will continue developing more relator diagrams. Since I have not found any other order 1 relator diagrams with no associated contradictory diagrams, I will begin creating an order 2 relator diagram. Again, it is necessary to create as many boxes as there are systems of 2 objects. As previously done, the next step is to add labels to the boxes and begin placing systems of 2 objects into the boxes. If a box is left unused, it can be removed from the relator diagram. Afterwards, the labels are changed and a contradictory diagram is searched for. The only diagram I was able to create was one that ordered all the objects backwards. However, this relator is not contradictory, as the order of the ordinal scale is retained. Assuming that no contradictory diagrams are ever created, this diagram is the relator's relator diagram. It is this diagram that will now be used to quantify the relator's usefulness. To think about the usefulness of a relator, we need to think about the 2 extreme types of relator diagrams. If a relator diagram has only 1 box, then every system shares the same property. However, if a relator diagram has the same number of boxes as systems, then none of the systems share the same property. I will make the assumption that the associated relators have the least amount of usefulness. This formula captures this notion quantitatively. As the number of boxes of a relator's relator diagram grows closer to the average number of boxes, it is considered to be more useful. For the specific relator in this video, it turns out that it has 3 units of usefulness. Thank you for watching.